All right, so we're continuing from yesterday's class. Let's start with forming solutions. So some of this we already did. We talked about solubility. The fact that a solute can dissolve in a solvent means that the solute is soluble. Solubility is just the ability of a substance to dissolve in a solvent. I had a student a long time ago made up a word. It's not a word. Dissolvability. If something is soluble, it is dissolvable. Is salt soluble in water? Is oil soluble in water? No. Okay. Now, this is where we left off yesterday. What about when you mix two liquids together? Like some of you are starting to drive. You're going to have to start taking care of your car. And one thing that you have in your car is called a thermostat housing. A thermostat housing is what allows for antifreeze and coolant to go through your car. We don't really have to deal with antifreeze here in Florida because it doesn't get that cold, but it does get pretty hot. So you have coolant in your car to make sure it doesn't get overheat and break. So they have a lot of mixtures of coolant and antifreeze, two different liquids mixing together. So when two liquids that are soluble with each other, or there's that made up word, dissolvable, this is known as miscible. Another vocab term. Yes.
Like with colloid, like with milk, you can't see like the milk and like the other parts. Is that how?
Okay, so if you want to say see, if you had a microscope, you could see.
So if you use a microscope on a solution, you
You can't see it. Nope. All right. Jade, is sand soluble or insoluble in water? If I took a little handful of sand, I poured it in water, I stirred it really good, would it dissolve?
No.
So is it soluble?
No.
Correct. Correct. This is where I get into insolubility, or just the word insoluble. A substance cannot be dissolved in a solvent. Like sand. Sand does not dissolve in water. It's too big. Yes?
Isn't salt water homogeneous and then like milk is heterogeneous?
Mm-hmm.
But can't you separate the salt from the water? I thought you can separate the salt from the water.
Not fully. Well, you can boil it through that, but that's where you're actually using chemical processes. But I'm talking about without temperature changes, just general. It's general state without affecting those conditions like temperature or pressure. All right. And then what do you think the word would be where two liquids do not mix with each other? If insoluble means it cannot, if a solid cannot dissolve in a liquid, what do you think the word is where a liquid and another liquid don't mix together? Immiscible. All right, so just like that, 4 more terms thrown at you. Okay. Do I have any? I'm gonna check see if I have some food coloring. Let me pause this for a second. This is gonna be section 13.2. Solution concentration. All right, so let me ask you this. Here's the turtle pond. And before last week, it was gross. It looked like this. Just pay attention. You don't need to draw a big green blob on your notes. Just watch. I mean, the water was just green. It was disgusting. I hated looking at it. The pump was broken. Well, we got it fixed. Now, something that I used to do is I would drain it halfway. And it was green like this, top to bottom. Just nasty. So let's say I drain this halfway. So it's now half full, but the water's still really bright green. And then I add clear city water to it. What am I doing to the water? And how would it actually look, Kevin? I am diluting it. So a dilution is reducing the concentration. So if I diluted it, Kevin, what color do you think it would be? It would probably be not as much of a potent green color as it was before. So maybe it might look something like this. See if I can get the right shade here. It probably will look something like this. So whenever you are diluting something, you're reducing the concentration of the solute. Now, by reducing the concentration of the solute, what do? Do you add more or less solute or add more or less solvent? Arshawn? In order to accomplish this, you need to add more solvent. And so what I would used to do is I just did this progressively, and it would take a couple days, but eventually the water would be nice and clear, kind of like how it is now. Yeah.
Does it have to be the same solvent that was first in the solution?
You want it to be, yeah. Now, the opposite of dilution is concentration. Or you want something to be concentrated. This is increasing the amount of solute. Now, there's a couple ways you can do this. Can you tell me what they are? Jade? Adding more what? You can add more solute. Or what else could you do? Yes, Arshawn.
Take out solvent.
You remove, or let me use a different word than remove, reduce amount of solvent.
For dilution, should you reduce solute?
If you can neutralize it. Yes, Nicole.
It seems like you would not take out the solute or you take out the salt and that one off.
That's the trick. Is you could either add more solute or reduce the solvent. So the one that I would think would be more ideal is this one. So if I have, like in your notes, you have a beaker here, and let's say this beaker is let's retry that. Let's say I have this amount of solution, and the solution is very, very dark blue. I want to make it a sky blue. Nicole, what would we do? Okay, so just add more of the solvent. Let's say the solvent is water. So we add more solvent, so it's going to dilute the mixture. That's known as dilution and concentration. The one on the left is more concentrated. The one on the right is more diluted. So this is concentrated. This is diluted when you compare one to the other. And if you want to get it really diluted, you probably have to fill it to the top and have it be like a really, 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 I guess, faint blue. kind of like this. And you would just have to keep doing this until it was all clear.
Does it always result in a color change?
If you have something that's color, yeah. It'll tip. When I would know that the water's getting cleaner when it's not as green. It's getting more and more clear. But if you have a solute that doesn't change the color, then not necessarily. What if I had salt in that pond? I would just have to do what I'm doing, and I would just have to know, unless I had like a salt kit where I could test the salinity, I would just have to keep pumping out the salt water and adding fresh water, and that would continue to dilute the fresh water, or excuse me, the salt water until it was more fresh. But you have things like salinity kits and other chemical tests like that. You guys have pools, okay? So I know a lot of you have swimming pools, I'm sure of it. Well, either your parents do it themselves or they hire a pool guy to test the pH. And when we get to unit 14, we're doing the pH level. Your pool has to be kind of basic to neutralize any algae growth. So let's say, I know that you're not familiar with this yet, but the pH scale is on a scale of 0 to 14. 7 is fresh water. Your pools are probably somewhere around a 9. Well, when it rains for a long time, do you think it makes your water more basic or more acidic? And keep in mind, it's fresh water that's falling from the sky. 7 is fresh water. So you're going to go more towards 14 or more towards 0 when it rains. Rain is going to cause the pH level to go down, maybe like to here. And when that goes down, that's how algae can actually form, because algae love fresh water. And so you always have to add those chemicals to your pool to keep that from happening. We'll get into that a lot next unit. Yes?
Wouldn't that make it less acidic?
It's going to make it more acidic. The closer you go to 0, the more acidic it becomes.
I thought like
7 is like nothing.
7 is neutral. It's even. So when you go this way, Carson, you're getting more and more and more and more acidic. When you go this way, you're going more and more and more and more basic. So if I'm going from a 9 to a 7, I'm getting less basic, more acidic.
I thought like fresh water is acidic.
It's like
But when you go from 9 to 7, remember, the closer you get to 0,
Okay, so no matter how much it rains, it won't go below 7.
it could potentially, but it shouldn't unless you have acid in the rain. It should hover around 7. My point is that whether I'm going from let me ask you this, because I'm getting off track here, but for the sake of discussion, if I'm at a 4 and I go to a 2, I go from 4 to 2, did I get more acidic or less acidic?
More acidic.
Okay, so the idea you need to get is just if you're going from a higher number to a lower number, you're getting more acidic. If I go from 13 to 12, am I getting more acidic or less acidic? More. And the opposite of that, the other side of that coin, is you would say, I'm getting less basic. Acid and base are opposites of each other. We'll get into all that next unit. Okay, let's get into this. Expressing concentration. So concentration, this will help you for not only this class, but future classes. Concentration is equal to something called molarity. Molarity symbol is a capital M. And to calculate molarity, you do moles per liter. Now, I want you to notice that moles is plural. This is one of those little tiny things that can go a long way. Moles is plural. Liter is singular. If I'm going 55 miles an hour, how many miles do I cover in 1 hour? I'm going 55 miles per hour. How far do I go in an hour? I go 55 miles. Miles per hour. Plural on top, singular on the bottom. Moles is going to be multiple, but it's always 1 liter. That's how you always need to get it. You always need to get it into 1 liter. So molarity and concentration, those two words are interchangeable. They're the same thing. Concentration is molarity, molarity is concentration. In my AP Bio class, they have to learn a formula called water potential. And a part of water potential is this. It's called solute potential. And the formula is negative I CRT. C stands for concentration. And concentration is molarity. Those words are interchangeable. And molarity is moles per liter. So just give me an idea of how this does come up in other classes. So the definition of concentration is how much solute is dissolved in a specific amount of solvent or solution. So again, this is moles per liter. Some things we're going to learn here, quantitative ways you can evaluate this. Is quantitative numbers or descriptions? Yes. 1 second. So ways that you can calculate concentration can be percent by mass. We're going to do that. Percent by volume, which is practically the same thing. Molarity. And everybody, molarity is a capital M. A lot of people like to italicize it. I'm not going to be a big stickler with that. But this one, molality, which we likely won't get today, is a lowercase italicized m. If you're wondering why does it have to be italicized, because meters and milli are already a lowercase m, but it's kind of like normal font. So molality, not molarity, I'm not misspeaking, I don't have a lisp. Molality is an italicized lowercase m. For someone who needed to go back up, is that high enough? Can you see? Okay, so I asked you to get out your calculators. I'm going to teach you all four of these. 1, 2, 3, 4, one at a time. Okay? One at a time. So I'll give you the tutorial, and then we'll do a practice problem. Tell you what it is, practice problem. Tell you what it is, practice problem. And that'll be your cheat sheet. Let's do the first one. You good, Francis? You got everything?
Yeah.
Okay, first one, percent by mass. Let's pretend, this one's easy. Total pretend. Let's say this entire class, all of you together weigh 1,700 pounds. Even, just pretend. I want to know what percent Max is of this. Max, how much do you weigh? Okay. How can I figure out what percent you are the entire class if the entire class weighs 1,700 pounds? That's it. So I want to know what percent is Max's weight of the whole class. Well, you just take Max's weight. You divide it by the class weight. And what do you multiply it by? Because this is a percent. 100. And that will equal your percent by mass. So if I did 120, you said 125 pounds, divided by 1,700, it's going to be a small number. .07, which is 7%. Max, if this class weighed 1,700 pounds, you are representative of 7% of this class. So let's put this in terms of chemistry. Percent by mass is the mass of the solute divided by the mass of the solution. Do you remember I said yesterday, whenever I write SOLN, that means solution, times 100. That's it. This equals percent by mass. There's your formula for percent by mass. Now, unless you have your PowerPoint open, I'm going to give you guys a practice problem. If you do have your PowerPoint open, you're going to see the little trick here. This is not as simple as and obvious as it seems. You got to use some brain power, my honors chem students. So let's do example problem 13.1. This is a percent by mass problem, okay? I'll give you a moment to try to figure it out, then I'll go over it with you. Here we go. In order to maintain a sodium chloride, which is NaCl, concentration similar to ocean water, an aquarium must contain 3.6 grams of sodium chloride per 100.0 grams of water, which is H2O, obviously. What is the percent by mass of sodium chloride in the solution? Okay, there's a little trick here. You guys are bright. See if you can catch it. It's not as obvious as it seems. I'll give you a couple minutes to work it out. Okay, I need you guys to help me out here. I'm just the messenger. You tell me what to write. What are my known values? Kurt? Tim, is this my solute or my solvent? This is my solute. And what else, Arshawn? Is that my solute or my solvent? What do you get when you combine a solute with a solvent? Okay. So we need to know our unknown, which is what is the percent by mass? of the solute. Okay, so it says that you need to have 3.6 grams per 100 grams of water. What is the percent by mass of sodium chloride in the solution? Okay. Anybody know what I should do? Arshan, go ahead.
Like the formula? Or like,
Well, just tell me what. Don't necessarily tell me the formula. Tell me this one is not as obvious as it may seem. At least I don't think so. So walk me through it with your classmates. What did you do?
Okay, so I added up to 3.6 to the final. Okay, well, it's 3.6.
Okay, guys, this wants to know the percent by mass of the solution. The solution is simply solute plus solvent. Solute, solvent, solution. So if you did 3.6 by 100, that's what I was afraid of. You're just doing salt divided by water. You're not doing salt divided by salt water. You had to find out the mass of the salt water. That's why I said it's not as obvious as you might think. I could see that trap happening. And then what did you do next, Arshan?
I did 3.6 over 3.6.
That's it. 3.6 divided by 103.6 times 100 should equal about 3.5%. So when I have 103.6 grams of salt water, we're at 3.6 grams of salt and 100 grams of water. 3.6 divided by 103.6, that's 3.5. Yeah.
We do 6 days.
Yeah. And it is in sig figs. Okay, I saw a lot of erasing going on. Did you see what I meant? Wasn't as obvious as you think. You have to get everything. You have to include the solutes and the solvents. Okay. Let's do percent by volume, guys. It's basically the same strategy. It's the same way. In fact, I don't even have a practice problem for this. It's the same thing. Volume of solute divided by volume of what? Solvent or solution? Solution. You gotta watch that. I think that's where some of you will make that mistake. You'll do solvent, not solution. You have to do the part divided by the whole. Times 100. Yes, David.
Or would we still convert to Kelvin?
This is volume. Kelvin is 10. So I can make up a problem like this. If you have, all right, I'll make this one kind of cheesy and gross. You have 0.4 liters of urine in a 2-liter toilet bowl. What is the percent by volume of urine in the pee water? This is actually going on YouTube. Okay, figure it out. Just made that up. It's really that simple. Learn your lesson from the last one. Like I said, a lot of you are making erasers. That's what school's all about. Learn from your mistakes. You're not on the record yet. Colby, what'd you do? Very good. 0.4 liters divided by 2.4 liters times 100 should equal about 17%. If you want to round that to sig figs, that would be 20%. Technically, I got 16.6, but that rounds up to 17. But again, sig figs, 0.4, 20. All right. All right, and this last one's going to be a good place to end class today. I already did a few of this already. I already talked about molarity, but to rehash it, what is another word for molarity? Let me use a different color here. What is another word for molarity? Concentration. They are the same thing. This just simply means how many moles of a solute are in the liters of a solution. Is it? The symbol for molarity is a capital M. And it is moles per liter. When you see that division line, that means per. Moles per liter, miles per hour, grams per liter, blah, 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 blah. For instance, if I had a measurement of 1 molar, we would say the words 1 molar. That's how you say the actual unit of measurement. You don't say 1 molarity, you say 1 molar. If I had 0.2 M, it would be 0.2 molar. That's how you actually say it. What would be more concentrated? 0.2 molar or 0.6 molar? What has more solute in the solvent or in the solution? That's more concentrated. Okay, this will be a great one to end today's class with. I'm probably going to give you guys a molarity homework assignment tomorrow. Think of it as a way to boost your grade. Do you know what IV stands for in medicine? Intravenous, in the vein. A 100.5 milliliter IV solution contains 5.10 grams of glucose, which is C6H12O6. What is the molarity of the solution? And to save you guys some time, I'll give you a hint, or I'll give you a clue to what you need to do. The molar mass of glucose is about 180 grams per mole. That's the molar mass. You'll need that. Let's see what you can do. Remember, you're not on the record. You're just learning. If you struggle, all good. We'll work it out together. Let's see if you can figure it out. It's 11:02. I'll give you to 11:05. And we're out of here at 11:10. I need time to explain it. Yes. Yes. It's a solution. So when you hear solution, it is already mixed. One more minute. I need 5 minutes to explain it. Okay, so reminder. You're trying to find the molarity. What is molarity? What over what? Moles of solutes. And what is your solute in this problem? What is the thing that is getting dissolved? Glucose. And you're dividing it over liters of solution. The solution is the IV fluid, the stuff that's going right into the person's veins. So do you have, in this problem, as it stands right now, do you have moles of your solutes? What do you have, Derek? You have the mass. Are you capable of converting mass to moles? Yes, and I gave you the key for that. So first thing is convert mass of glucose to moles of glucose. I gave you the molar mass. So you want to start with 5.10 grams of C6H12O6. Where did I get that number? That was in the word problem. You're then going to divide it by the molar mass. You'll put 180 grams of glucose on the bottom, 1 mole of glucose on top. This should equal, let's see, is that right? Hold on, I can't be right. Yeah, that's right. 0.028 moles of C6H12O6. Okay, you now have moles of glucose. That's what you're going to put on the top. Now, listen up. Do you have liters of your solution? No. You have milliliters of your solution. So you now need to convert, and this is not always the case, convert mLs, which is milliliters. A lot of people in hospitals will say mils. It's just the milliliters to liters. How many milliliters are there in a liter? 1,000. So 100.5 milliliters. 1,000 milliliters on the bottom, 1 milliliter on top. That's going to equal 0.1005 liters. Okay, Chem kids, do you have moles of your solute? Now, yes. Do you have liters of your solution? Just divide. 0.028 divided by 0.1005. 0.028 moles divided by 0.1005 liters. That should get you 0.282 molar. That is the answer. Yeah.
Does it not matter that the liters is not 1?
It doesn't, because what it is now, Arshawn, is when I say 0.282 molar, you're basically saying, and this is a good point for you guys to learn since you're just learning this, you can also say this, 0.282 moles over 1 liter.
When you're actually doing it, liters doesn't have to be 1.
No. But when you do the division, it's going to end up as 1. All right. We'll continue this tomorrow.